Hi everyone in Algebra 2B. Today we're going to be going over your questions for lesson 102B. And the first thing that we're going to do is start with number 16. And when I do number 16, I see that I have to evaluate the top equation to set it equal to y so that I'm able to graph this. So I'm going to have negative 5y is less than negative 3x plus 10. Then I need to divide out everything by negative 5. So remember that when you divide by a negative, you also need to flip the sign. So this sign is going to flip. So that would be y is greater than positive 3 over 5x and then minus 2. So the first thing that I recognize is that this is going to be a dotted line. And then when it says greater than, it's going to shade everything above that line. And for this one, it's going to be a solid line. So negative 2, and it's greater than, so that's also going to shade everything above. So negative 2 on the y-axis would be right here. And I'm just going to draw a solid line through negative 2 on the y-axis. And that will represent my first line. My second line is going to be to cross at negative 2 as well. But it actually has a slope, and that slope is, so it's going to be at negative 2, and then it's going to rise 1, 2, 3 over 5. 1, 2, 3, 4, 5. Or you can go down 3, 1, 2, 3 over 1, 2, 3, 4, 5. So something like that. And this is going to be a dotted line that goes through those points. Oops. My line kind of slants. So now what we're going to do is we're going to shade the regions that satisfy. So the solid line, I'm going to shade everything above it like this. And for the second one, I'm going to shade everything above this slanted line. So that would be everything up here, everything above it. So my answer is going to be the region that's covered by both, and that would be the region above both of these lines. So above the slant line and above the straight line. And that would be your result for number 16. Now moving on to number 17. First thing that I'm going to do is I'm going to move the 2 to the other side. So I'm going to subtract 2. So I have x is less than negative 2. Then for this one, I'm going to move the 3 to the other side. But I also forgot to deal with this inequality. So if the inequality has a slash through it, I have to flip it and make it negative, and take away the equal sign. So I would make this x is greater than 0. My domain is integer, so that's going to be points on the line, not a dot with an arrow. So I'm going to draw my number line, negative 3, negative 2. This is my number line. So on negative 2, it's not going to be filled in. And then on 0, it's also not going to be filled in. So on both of these numbers, negative 2, everything less than negative 2 would go to the left of negative 2. So I would fill in the dots to the left of negative 2. And then for 0, I fill everything to the right of 0. So that would be 1, 2, and that would keep on going in either direction. So integers are points, not going to be just that arrow that encompasses everything. Now looking at this next problem, which is going to be finding the number that's a fractional distance away from 2 points. That one, we actually have a formula that we're going to use, and that comes from lesson 98. So number is equal to the first number plus the fraction times second minus the first. And the order in which the numbers show up are going to be fraction, first, second. So my formula is n is equal to the first plus the fraction times second minus the first. And the order it shows up is going to be fraction, first, second. So we're going to plug in those variables. So first number is 1/5. Fraction is 1/8. Second number is 2 1/3 minus first number, which is 1/5. Now what I want to do is make that into an improper fraction, and then I'm going to need to subtract the two from each other. So everything else, the 1/5 and the 1/8 stays the same. Do not add them together. I repeat, do not add these together. So this would be 7/3 minus 1/5. And the common denominator is going to be 15. So I'd multiply that by 3, that by 5. Again, 1/5 plus 1/8. But remember, order of operations means we have to do parentheses first. Then we're going to multiply before we add. So 35 minus 3 will give us 32/15. Fortunately, 8 does go into 32 4 times. So really what we have is 1/5 plus 4/15, making our common denominator 15 again. 3/15 plus 4/15 would be 7/15, and that would be a result for number 18. Now looking at number 20, the first thing that I'm going to do is add the fractions that are furthest in the denominator, which would be these down here. And the common denominator would be x. Everything else is going to stay the same, so don't change anything else. That would be kx minus 1 all over x. Now we're going to flip this, so I'm going to multiply this denominator by this numerator. Everything else stays the same, so kx over x minus kx squared over kx minus 1. You're going to make a common denominator, so we're going to multiply top and bottom by that kx minus 1. So this would be kx over x times kx minus 1, then minus kx squared all over kx minus 1. You are going to end up multiplying this denominator by this numerator, but I do need to distribute this x as well. So when I multiply the numerator, it would be kx times kx minus 1 over, and that would turn into kx squared minus x minus kx squared. And what you should recognize is that these kx squareds are actually going to cancel. Also, that there's an x on top and bottom that would cancel. And then this minus sign would go to the numerator. So your answer would be negative k times kx minus 1, and that would be your result. So there is some simplification that could happen on that problem, so you did need to make sure that you worked that problem out fully. Now moving on to number 24, so we're going to diagram this first. So it's going to the right 4 spaces, then going up 10 spaces. So to the right 4, up 10, have to find the hypotenuse as well as the angle. Use Pythagorean theorem to solve for the hypotenuse. So h squared equals 10 squared plus 4 squared. 10 squared is 100, 4 squared is 16. So we get h squared is equal to 116. And that would turn into 2 square root 29. Now our angle, so we're going to use inverse tangent. And that's going to be from this angle, it's opposite over adjacent, so 10/4. In your calculator, you evaluate this by doing 10 divided by 4 equals, then you do second tangent. And that gives you your angle of 68.20. Because it's in quadrant 1, you do not need to change that at all. So your answer is just going to be 2 root 29. And your angle is going to be 68.20. Okay. Now for number 25, the first thing that I'm going to do is I'm actually going to eliminate the denominator by multiplying this entire thing by the common denominator, which would be x times m plus c. So what you should recognize is that when I multiply the first fraction by x times mc, I'm really just multiplying the numerator a by m plus c. So I'm going to distribute that. That would turn into am plus ac. My second fraction, the m plus c would cancel, so that would just turn into bx. My right side, I'd have to actually multiply by the whole thing, so that would turn into amx squared plus acx squared. We're solving for c, so everything that contains a c, I'm going to move to one side. So I'm going to move this acx squared to this side, move everything else to the right-hand side. So that would become ac minus acx squared equals my amx squared minus the am and then minus the bx. I'm going to factor out a c from the left-hand side. So that would be a minus ax squared. Right side stays the same at amx squared minus am plus minus bx. Then we're going to divide by this parentheses. So your result is going to be c is equal to amx squared minus am minus bx all over a minus ax squared. And that concludes number 25. Now the last problem that we're going to look at is number 30, and I have to read that problem from the book. So it says, if the line AB intersects the line CD at point E, which of the following pairs of angles need not be equal? So if I draw two lines, let's call this line EAB. And then I'm going to draw another line here, call it CD. And it's intersecting at point E. So it says which ones are not equal. So AEB and CED, where AEB is a straight line and CED is also a straight line. So A is going to be equal. Okay, B is angle AED. So AED would be here, and CEA would be here. So B is not equal. Let's check the other ones. So the other one would be angle DEC, which would be the whole line, and BEA, which would be the whole line. So C would be equal. The next one, AEC. AEC would be this angle here, that first black line, and BED would be here. So those would be equal to each other. So D would be equal. Let's go to the next one. It's E. Oh shoot, I messed that up. That should be B. This is actually C. Wow, I'm not doing well. So C is not equal. This line is actually E, which is equal. This line's actually B. And then the next one is D. Did this way out of order. So BEC would be this angle here, and DEA, which is this angle here, and those are equal to each other as well. So the only one that is not equal to each other would be C. So your answer is C. So you're just trying to determine which ones were not equal to each other. Now that concludes your questions from 102B. And for those of you that did watch this video, you need to make sure you're checking your red one, because there is some information about a test next week, as well as an extra credit thing on RunWeb. So I would make sure to check that out. And I hope you guys all have a great weekend. Make sure you watch the video for lesson 103 and post your questions for 103A by Monday morning. Hope you guys all have a great weekend. Bye.